Today we are going to examine type 3 projectile motion. Type 1 projectile motion is from a cliff, some tower where it's shot horizontally and you have a parabolic trajectory. Type 2 is when it is launched from a surface at an angle and the projectile lands at the same surface level in which was fired. Type 3 is a projectile is launched from a tower or cliff or some height. We're calling it dy1. We're saying that this is 1,000 meters. And it's launched at an angle and it lands at the base of the cliff or the tower. Now, let's look at a couple of parameters. This point, the max height, the max d, the maximum distance in the y direction, the time in which it takes to get there, we're going to call t1. The amount of time it takes to get to here, we're going to call time 2. The height of the cliff, we're going to call dy1. The height above the cliff relative to the max height, we're going to call dy2. The distance between the base of the cliff and the vertical line drawn to the max height, we're going to call dx1. And the distance between the vertical line drawn to the dmax and where the projectile lands, we're going to call dx2. Here are the various values we're going to solve for. Now, we have to know what's given. What's given is simply 100 meters per second is V0 at 60 degrees from the horizontal. So we can put that in. 100 meters per second, 60 degrees. Now, we're going to put I'll use this area here as my scratch area. I'll do my calculations here. As you remember from yesterday, Vx is V0 cosine theta, and Vy is V0 sine theta. (100) cosine 60. 100 cosine 60 is what? 50. (100 sine 60 is 86.6. Remember the rocket problems. Vy, how long does it take to get to the max? You're going to divide by g. Simplest thing to calculate. We're going to round g to 10 meters per second squared. 8.6. So, 86.6 divided by 10 is 8.7 is fine. 8.7. How long is it going to take if something's going to fall
17.
from rest? seconds.
17.4.
How long is it, how far is it gonna fall? Anybody? What is 5 T1 squared? What is 5 times 8.7 squared?
378.45.
So 378.
Yep.
A 1,000 is also given. I neglected to put 1,000 down for dy1. This is not drawn to scale. This is not drawn to scale. This is 378 and this is 1,000. So the total height is going to be 1,378. We go from here, that point there, the maximum dy to here is the same time it takes to simply go from here to here. We're going to call that T2. How do you solve T2? The dy total divided by 5, so root, before you answer, let me just show you. So it'll be T2 equals 1,378 divided by 5. What do we get? T2 is what?
16.6.
16.6 seconds. 16.6 seconds. Now, you remember the basic equation V equals D over T. You remember the basic equation V equals D over T. D equals VT. Correct? The distance in the x1 value is Vx T1. Vx T1. Vx T1. 50 times 8.7 equals 435. 435 meters. dx2. 50 times 16.6. 50 830 meters. 830 meters. $830 plus 435 meters, 1,265, correct?
Yes.
1265. 1265 meters. Total height, 1378 meters. Total horizontal displacement, 1265 meters. What did I do? Step one. Convert to components Vx and Vy. Next, get T1, Vy divided by G. Next, how far is that? 5T1 squared. Find dy2, add it to dy1. Find T2. Then calculate dx1, dx2, and put in your totals, and you're finished.